Today we're going to talk about virtual machines. Virtual machines allow you to create a layer of protection for your privacy and to prevent hacking. Does it live up to the promise? In this video, we will install a virtual machine and then do a performance comparison between a virtual machine VM and a native machine. And then we'll examine how a VM can help you or not. Stay tuned. First of all, just a quick definition. A virtual machine is a computer file, typically called an image, that behaves like an actual computer. In other words, creating a computer within a computer. When you run any apps inside the virtual machine, the apps don't necessarily know that they're in a virtual machine versus a physical computer, or what I call the native computer. For this video, I'm going to install a virtual machine manager on Windows 10, and I will install Ubuntu as the virtual machine operating system. The product I will use as the virtual machine manager is called Oracle VirtualBox. Now, there are many VM managers out there. On Windows, there's VMware. For a Mac, a popular one is a product called Parallels. And on Linux, there's GNOME boxes, KVM, Xen, and there's a processor emulator called QEMU. And that allows for you to emulate ARM inside x86, for example. Now, some of these are specialized and can get kind of advanced, and some of these are command line and made to run on servers and not a desktop or laptop. But one thing that runs on all of these platforms is VirtualBox. So this is what we're going to use today. And it's the simplest. You can install VirtualBox on Mac OS, Windows, and Linux, and it pretty much runs the same way on each. VirtualBox is not the fastest, but it's free. Virtualization technology has been around for a long time. In fact, when you rent a shared server to set up a website, you're actually renting a virtual machine. You don't have control of the physical device. Your vendor manages that, and you just get control over your own space, which is that virtual machine. What we will do in this video is to install a VM on your desktop computer or laptop. Virtualization tech has come a long way from its beginnings. For one thing, the processors are actually geared to handle virtualization, so the overhead to running a VM has gone down quite a bit from the old days. So if there's a time when we can do practical things on our computers with a virtual machine, that time is now. Newer computers will be very comfortable with a VM running. On some Intel machines, virtualization may not be allowed by the processor, and this has to be switched on in BIOS. So you may have to go to BIOS setup and enable Intel virtualization technology, or sometimes it's referred to as Intel VTX. And on AMD, it's called AMD V. So if you try what we're doing here on your computer and you get some virtualization errors, you may need to enable it in the BIOS. For the most part, modern computers have this enabled. Now, what's the advantage of a virtual machine? When you go on the internet, your device will emit many identifiers that reveal what computer you have and the OS. And together with specifics on a browser, this information can be used to do what is called a browser fingerprint. If you're running websites like Facebook, Facebook will track your movements on the internet even when you go to other websites that have nothing to do with Facebook. Facebook will match little breadcrumbs of your Facebook account to whatever you do. If you run Facebook in isolation on a VM, basically Facebook can't get extra information. This is the same as dedicating a separate computer just for Facebook. A separate computer and a separate network. One of the most insidious data breaches of Facebook is when they capture the IP addresses of devices on your local network. And here's where a VM shuts this down completely. When you use a VM, the VM actually starts its own network subnet, meaning it appears to be a separate network. So other devices on the network are no longer visible. This prevents Facebook from spying on your network. It also prevents any hacker from seeing your network and other devices on it, even if they manage to hack your computer. So it's very good for security isolation. Many of you now work from home using your home computer to access your office network. By using a VM, someone at your office cannot see outside of the scope of the VM, and you're free from corporate spying. So this keeps your personal files and network safe and private. Here's another interesting piece of info. Most hacks occur because of email. In another video, I recommend resetting your computer on some regular interval, like every few months. The reason is that you may not know that you've been hacked. You know how difficult it is to reinstall all the apps all over again and put in all your data. The solution is to create a backup of a VM and then on a regular basis reinstall a new VM, so you're always starting from a known fixed point with all of the apps installed. This keeps you in control. If you're afraid of being hacked all the time, this is the way you can do the equivalent of a factory reset. Now, since most hacks come from email and going to websites, compartmentalizing your activity inside a virtual machine will ensure that your host computer is safe. In fact, you may want to set up a computer without email on the host computer or the host OS and put email only on a virtual machine. Now, how does a VM interact with the host system? The VM still needs the hardware of the host physical computer. So it will use the same network card, the same hard disk drives, the same displays, but it will be isolated in memory by the virtual machine. This is very important to understand. The VM will use the same network as the host computer. So whatever IP address you're using on the host computer will still be used by the VM. The VM will not see if you're connected via Wi-Fi or some other method. To the VM, the network will appear to be wired. Now, why is this important to understand? Since you want to protect your IP address, the host computer network still needs to run on a VPN or Tor routing for protection. This is not an element that a VM can protect. In this demo, I will install Ubuntu over Windows 10, and then we will run Ubuntu to go visit YouTube. To YouTube or any external website doing device fingerprinting or browser fingerprinting, you will appear to be running Ubuntu, and hackers will see that you are running Ubuntu, even though the host system is Windows. Outsiders will have no idea that you're actually running a VM over Windows 10. Since Linux by design is much harder to infect with viruses, by its nature, using a Linux VM over Windows 10 will make you less vulnerable to getting hacked. The less apps you run on the host OS, leaving those apps to run on the VM, the more protected you are and the less chances of having to do a factory reset on the host system, which is Windows 10 in my example. Also, because you don't have much data on the host system, it's easier to reinstall it even with a virtual machine. Virtual machines are also great for testing out a new Linux distro or even testing out new versions of Windows. Just a cautionary note, if you're running Windows 10, you will have to do some tweaking to allow your VM version of Windows to be licensed automatically. I will leave some links in the description to discussions about that. Now, let me do a quick virtual machine installation. In reality, this took a long time because of downloads, so I will speed up the process whenever there's a wait. But this will be complete. At the end of the install, I will do a side-by-side comparison of the performance of the computer running a YouTube video inside of a VM and without the VM. Okay, let's get started with the install. Just so you're aware, this computer is an HP Spectre X360 with an i7 8550U CPU. It's a little over 1.5 years old. First, let's install VirtualBox. The official site is virtualbox.org. Download and install it based on which host computer you have. For this demo, I will download the Windows version. Then I will just click on the installation file and run it using defaults. I already have it installed here, so it just replaces the existing installation. Before we actually make a virtual machine, let's download the OS we are going to install in advance. So in this case, I will install Ubuntu 20.04 LTS. So the file you get from Ubuntu will be an ISO file or a disk image of the installation. You will set that aside and make sure you know where to find it. I will now start VirtualBox and I will click on New. I'll name my VM Ubuntu and select type Linux and version Ubuntu 64-bit. I think I've seen some tests that show that running some 32-bit version of Linux might be more efficient with resources. But Ubuntu 20.04 LTS comes only 64-bit, so we'll have to stick to that. The only thing that I will really change on the default installation is the memory size. I'm giving the max memory that I can give to my VM, so I'll go near the end of the green line. I select create a virtual hard disk, leaving it to the default of VDI and dynamically allocate it. And then you can set a limit on how much space you will allow the VM to consume. I'll just leave that to the default for now at 10 gigabytes. You can tweak it later as you use it more. And that's it. Now I'll start the new VM and it will act like I just booted the computer from a CD-ROM. So point it to the Ubuntu ISO that we downloaded earlier and it will begin the slow setup. I pretty much leave everything to default from here. Again, you can modify this after the installation. So just like a Linux CD, it will start up and give me the option to permanently install the OS, and I will allow it to do that. It will give scary messages like erasing everything and so on, but really it will only have access to the virtual machine drive, so it can't really mess anything up. This installation took a very long time, more than half an hour, so I will just speed up the video. Now at the end of all this, it will start Ubuntu up for the first time. the most important thing I will want to set up is the display setting. By default, it starts out with a display resolution of 800 by 600. So I'm sizing mine a little bigger, but not the full screen since it doesn't have the exact size of my display on Ubuntu. So there we go, we have Ubuntu installed. Let's say for the sake of brevity that you've configured Ubuntu the way you want with all the applications you need, and now you have a base system that you know is ready for use and has not been hacked. You can do a process called cloning. By cloning a VM, you can make an exact copy, and if you ever want to replace your currently used VM, just delete it and make a new clone to use, and you're back exactly at the beginning. The next step we're going to take is to compare the performance of a virtual machine running a YouTube video over Firefox and the same thing over the host native machine. The point of this exercise is to see how much of a performance hit you will see with a virtual machine. Back in the old days, the hit was very high, like 20 to 30% of the CPU being consumed by the VM. Let's first look at a baseline. Here I have Windows running Firefox on the native machine. I'm on YouTube, but I haven't started a video. By the way, I let this settle down a bit to make sure that there are no major background jobs running. And you can see that the CPU usage is low when you're not actually using the machine and no VMs are running. Now let's start the virtual machine. Again, I will run Firefox on YouTube, but no videos running. You can see the small overhead from the VM. Looks like around an extra 2% of CPU or so. Now we will run a video on the native machine and watch the performance of the video and the graphics. I see around an extra 4% with a video running. Now we will run the video on the VM and see how the CPU performs with the GPU. And here it's going from 12 to 26%. So I'm going to guess there's an overhead of 15% or so with the video above a native host. In reality, I can tell you that the graphics acceleration is not fast. Sometimes the video will drag a bit. But part of this is because I did not configure the VM with video acceleration. You can do this in the system settings for the VM and it will make a big difference when set with video acceleration. The overhead will be around 10% or less from what I've seen. My conclusion on performance. For most common uses, I think it will perform just fine doing the most basic things we do on a computer. There's not a big effect on CPU load being on the VM. Now, since video is affected, this could be because Ubuntu doesn't have graphics acceleration enabled, at least to the degree it is on the native machine. So that can be improved with tweaking. I probably would not be comfortable doing things like video editing in a VM. That's probably too CPU and GPU intensive. But for most things I do, including programming, a VM is fine. It takes some discipline to be using a VM. One of the ways to run a VM, by the way, is to install WHONIX on the VirtualBox. WHONIX is a secure version of Linux that runs in a virtual machine. In fact, it is made to run on VirtualBox. The difference with WHONIX is that it routes all your traffic through Tor in addition to being a Linux distro. This will obviously make everything slow, but it will be extremely safe. If you already have VirtualBox installed, you can install Linux as one of your VMs, so you have a Tor option available to you. WHONIX is actually going to use 2 VMs at the same time. One VM to handle the Tor routing and the other for the user interface. I've used WHONIX extensively for a long time. I used it a lot on a MacBook Pro actually, and it ran fine. If you want to run a more hardened computer experience, you can run your email on Thunderbird under WHONIX, and then you will be certain no one will get your IP address from your emails, even if you don't have a VPN. Hope you learned something. Please let me know in the comments below if there's some more important topics you want me to cover. This was requested by many of you over time, so it was time to get it done. Please support this channel by hitting that subscribe button and hit the notification bell as well, so you're early to my videos, which I scheduled to release on Thursday mornings Pacific time. Thank you for watching.